Hi guys, welcome back. We're having a look at the floor plan for the same project now. You'll notice I've changed my mouse pointer options so that it's a bit easier for you to see. We've still got north pointing in the same direction, heading down to the bottom left-hand corner there. Now this time the floor plan is a different scale. The scale is 1 to 100. So that means every millimetre on this drawing equates to 100 millimetres in real life. So the 3050 millimetres shown here would, if I was to measure it at a scale of 1 to 1, equate to 30.5 millimetres. Okay, so if you don't have a scale rule and you need to draw something to scale, all you need to do is divide it by whatever the scale is, and that's what the actual millimetres are. Okay, we've got the same council approval, we've got the ABSA certified approval there. We're now looking at drawing 5 of 9, so nothing else has changed. We've got the same notes down here about making sure they're in accordance with ABSA and BASIC certificate specifications. Now, looking at the floor plan of the house, what it does is just give us a layout of all the rooms, locations of stairs, kitchens, bathrooms, toilets, laundries, and so on. And it also shows us the level, the reduced level. Say, for example, here in the garage, we've got 26.9, which was down from that 28.72 benchmark. And then we would walk through a cavity sliding door, CSD cavity sliding door. It's one of those doors that slides into the wall frame. We come into our front entry. We're actually going down the stairs here onto the main lounge area here. Lounge, kitchen, dining, bedrooms and all that, those other rooms. So they are what? They are 625 millimetres lower here than the garage. So we've gone through the door, down the stairs, into this area. This is all on the same area, the bathroom, laundry, bedroom, and all that area. We would go up a number of stairs here and go up another 590 millimetres. Yes, I was just checking my maths. Okay, so the layouts are always generally the same. You get the same information off them. In the kitchen area here, we've got a cupboard, we've got a refrigerator, a small pantry, a hot plate, that'll be a sink looking out through a window, and we've got a breakfast bar here. We've been given the information of how long this return is because we've got a dimension there of 2400 from the internal walls. That's how long that is. But we don't know the width of this gap here to this island. We don't really know the dimensions of the island either. So there's information missing in this drawing here. We don't have the dimensions of where this wall, how far this door is here. We'd actually, we would be able to calculate it, but there's a bit of stuffing around there on the part of the builder or the there's a bit of extra work anyway because the architects haven't provided all the necessary information. Now, looking at the dimensions, basically what happens with all projects is the further away from the actual building, the dimensions are giving us the overall length and the width of the building, and that's what we've got here. Across the top of the drawing and the bottom of the drawing, and it's always good that they both match up. And believe it or not, I worked on a big commercial job years ago where it took the architects ages and ages to get the dimensions to close around the outside of this office tower. So that was before the days of CAD drawing. 12,980 overall width, and then we've got up the left hand side 14,540 overall distance there. What happens then is as we move closer to the actual building, we start picking off the dimensions for external rebates in the wall. So we've got a veranda there on that end, and down here we have another rebate here, so we get the dimension of the length of the veranda there. And we'll have the same sort of thing with the width. So we've got the overall width, and we start picking off that rebate, the width of the rebate, the width of the veranda. Okay, and the same thing at the back there. The 9220 comes away from the 12980 and gives us the 3690. Okay, and then we move closer in again and we start looking at the internal walls, the distances. So we can actually set out all our internal walls. We've got more dimensions over here. Now, one thing you might notice is the external walls are 90 millimeters and the internal walls are 70 millimeters thickness, and that's the actual thickness of the timber. We're not showing the cladding on the internal and external surfaces there, because that could vary. If, for example, we were building a brick veneer building, we would have a brick skin, a cavity, and then we would have our internal framing. So we might have a dimension of something like 225 to 250 as the overall width of the external walls, whereas the internal walls would probably still show up as 90 or 70, depending on what's been chosen. Bathrooms, laundries and kitchens are usually easy to sort of spot on most projects. The laundries and bathrooms in particular have always shown with floor tiles hatched. And in here we've got the laundry, we've got the laundry tubs, a washing machine and a toilet. Toilets might have the letters WC for water closet or LDS for low down suite. All in all, it's still a toilet. Okay, here we have an internal wall here at this position here. Then we've got a shower, SHWR, I think that says. I can't really read it. We've got a bath, another toilet, a vanity unit. So a vanity unit is just your basin in there. And they're all actually shown at the same floor level as the main lounge room here. So that's all at one level there. Then we sort of go up a couple of steps here into the 2 bedrooms at the front of the house. And you'll notice that they are 65 millimetres above the garage floor. Okay, we're going to come down. So basically you can pick off the overall dimensions, and as you move closer to the building you're getting more and more detail. These little horizontal lines that come out from the building are what we call witness lines, and the diagonal slashes indicating the extent of the measurement. So this 600 here relates to that internal measurement there. We're also shown on the notes here that we've got timber steps, 1,000 high selected balustrade. A balustrade is that bit of framework with a handrail on top that stops you falling off the edge of a landing or a deck, and also runs down the side of the stairs to stop you falling over the sides of the stairs. Okay, so what we have here, believe it or not, is a U with an arrow pointing in that direction. Exactly the same as what we've got in these stairs here in the centre of the house, and leading over to the bedrooms. So the stairs are always supposed to be shown with an arrow pointing to the direction that's going up, and they would be numbered at the bottom. The rises, the vertical face of the steps would be numbered 1, 2, 3, 4, etc., heading upwards. Okay, we've got a timber floor construction, plasterboard sheeting internally, it's all standard. We don't have any information on paint finishes and things like that because it's not worth showing here, and it's a variable. We've got down in the garage, we've got a RC floor slab, a reinforced concrete floor slab to the engineer's details. Builders and architects don't design any of those structural components. We leave that to the structural and civil engineers who've spent 4 years at uni perfecting their skills in being able to provide accurate designs. And legally, we're not entitled to do that, and nor would we want to. That's part of risk management. Let them take the risk. They're charging us good money for it. Okay, that's pretty much about it on the drawings here. I think we'll go and have a look. Oh, no, beg your pardon. What we'll do, look at the windows. What we would normally have is door numbers and window numbers. So here we've got window 1, 2, round the side, 3, 4, 5, 6, and so on, round to window 9 in the garage. We don't have window widths here. What we would then expect is that they would show up in the elevations, or maybe they would show up on a window and door schedule. And I don't know if we've got one of those in this set of drawings, but we'll find out. Okay, well, we've got a 2100 wide sliding door there. So when we actually look at its window schedule, it comes, because the windows are generally aluminium and the sliding doors are aluminium framed, what we would get is here we would get the code would probably be SD2118. Beg your pardon. Here the code would probably be SD2121, because normally the sliding doors are 2100 high and here it is 2100 wide. If, for example, this was 1800 wide, my sliding door code would be SD2118 to indicate 1800 wide and 2100 high. In any event, that changes from manufacturer to manufacturer. So we've also got down the front here timber veranda construction, selected boarding, the same as at the back of the house, and we've got a timber veranda post with a roof beam over. That can lead to variations because we could go out and pick a number of different species of timber with different finishes, and they would all cost different amounts of money. So that's something we need to sort out with the client. We've also got here 4800 wide selected garage door. So that needs to be specified because there's a big variation in the cost of doors as well. Okay, so now we'll go and have a look at the elevations.